Hello viewers, I am Kausalya. Today we are going to see the steady state error when the input is step signal derivation. So to start with, you must know what is a steady state error. To know this, kindly check the link in the description below. Now we will start the derivation. So the steady state error is given by the formula E of s is equal to limit s tends to 0 s into r of s divided by 1 plus g of s into h of s. Right. Now what is the unit step? For unit step, what is the value of r of s? It is nothing but 1 by s. So here we are going to substitute the value of r of s as 1 by s in this expression. So here this is our expression. E of s is equal to limit s tends to 0 s into r of s divided by 1 plus g of s into h of s. Now here we know the value of r of s is 1 by s for unit step input. So just substitute the value 1 by s here. So when you substitute, this s term will cancel each other and finally we will be having an expression as 1 divided by 1 plus g of s into h of s. The next thing is, here the value of 1 is constant and again here the value of this one in the denominator is also a constant. So here we are applying the limit s tends to 0 only to this part. So I am shifting this limit s tends to 0 inside. So our expression becomes 1 divided by 1 plus limit s tends to 0 g of s into h of s, because here there are no s terms, right? So this 1 and this 1 value will always remain as 1. So here the only thing variable is, here there may be s term. So I am moving this limit s tends to 0 inside here and finally we are having an expression like this. Right. So here this is then expression for, that is, limit s tends to 0 g of s into h of s is nothing but kp. This is known as positional error constant. So here instead of this term, I am replacing this term with kp. So finally the steady state error is equal to 1 divided by 1 plus kp. This is our final expression. Right. Now we are going to analyze this expression whether it suits for type 0 system and type 1 system. So first we are considering a type 0 system. So type 0 system, as we all know, this term, the denominator part of this term won't have any s term. So here kp is given by the formula limit s tends to 0 g of s into h of s. So here the general form of representing an expression is given by this way. That is k into s plus z1, s plus z2, s plus z3 divided by s plus p1, s plus p2 and s plus p3. That is, z denotes zeros and p1, p2, p3 denotes poles. Right. So here when you substitute the value of s as 0, that is 0 plus s1 will become, 0 plus z1 will become z1, 0 plus z2 becomes z2 and similarly 0 plus p3 becomes p3. So here these terms all are said to be constants, right? Because only the term when you are having s, that value moves to 0. When once the thing moves to 0, we are getting constants, right? The z1 may be of any number. So here all these terms are constant. So finally the output is also a constant here. So now we are substituting in the steady state error formula. The steady state error is given by 1 divided by 1 plus kp. Here what is the value of kp? Here the value of kp is a constant. So when I substitute the value of constant here, again the final answer will be a constant. Right? So for type 0 system, the steady state error is a constant. Next we are going to see type 1 system. So again, what is the formula for kp? Kp is given by limit s tends to 0 g of s into h of s. And what is the general format of representing this g of s and h of s? It is k into s plus 1, s plus z2, s plus z3 divided by s plus p1, s plus p2, s plus p3. Here, what is the type of system? It is type 1 system. So this denominator term will have an individual s with the power 1. Right? Yes. Then the next thing is we are going to substitute the value of s as 0 here. So when you substitute the value of s as 0, here the numerator term will have some constants, right? It will have some, that is what will be the expression? They will be having k into z1, z2 and z3 divided by, here the value of s will be 0. So 0 into anything will be again 0. So anything divided by 0 is nothing but infinity, right? So here the value of Kp becomes infinity. Now I am going to substitute this value in the steady state error formula. So steady state error is given by 1 divided by 1 plus Kp, and here the value of Kp is infinity. So I am substituting this infinity here. So anything divided by infinity becomes 0. So for type 1 system, the steady state error is 0, right? Hope you people understand the video. Thank you.